Yes or no? How much is it? We know the center of the rectangle. How to get the rectangle is YC is not YC equal, suppose it's BY, it's BY, it's the area is suppose is B is H, it's not the YC times A is not must equal Y dA equal Y B dy. Yes or no? The distance is Y. Yes or no? dA is B dy from half H. Yes or no? B is a constant. It can move B Y dy. Yes or no? We know from here we know is a constant because this part is we can know this part is 0. Yes or no? Because this part, because from the equation we can get Y dA must equal 0 integration over the entire area. So because we know this part, when this part is 0, we know YC is 0. Yes or no?
Yes.
When this part is 0, YC is what? Is 0. So we can determine from this formula neutral x must pass through the center of the cross section. In this way, we find the location of the neutral x. Understand?
Yes.
So when the book is banned, where is the plane? The length doesn't change. The middle plane. Because the neutral x passes through the center. So we can know the neutral plane is the middle plane. Yes or no?
Even in the
The neutral plane is the middle plane. After we know the neutral plane is the middle plane, we know the internal band is M. Yes or no?
yes.
Now I erase it, maybe erase it because we know where is the neutral x. We know where is the neutral x. Because from the formula we know is the rectangle, then is the rectangle B. Yes or no? So we can make a cross section. Is a cross section. This is the neutral axis. Look at the on the cross section is the neutral axis. The neutral axis passes the center
Yes.
of the rectangle. The upper part, the top part is in compression. And the stress is proportional to y. Yes or no? It means when y is 0, the point is in the neutral axis. In the neutral axis, when y in the neutral axis, y is 0. Yes or not? When y is 0, it means neutral plane. So when y is 0, the sigma is the neutral axis. Is the point on the neutral axis. Yes or not? So we know the neutral axis. The normal stress on the neutral plane or the neutral axis is 0. On the top surface, y is the maximum. So it's getting, so the stress, the normal stress come to its maximum value. So we can get it. This part is 0. Oh, it's in compression. Yes or no?
Yeah.
It's in compression. For this part is in tension. Understand? So this is the distribution of the normal stress on the cross section. Understand? Suppose the beam will break. Where is the point? The correct first appear.
The bottom.
It must be on the bottom
Yes.
of the beam because it's sigma max. Yes or not? Or if the material is weak in compression, it will be at the top surface of the beam. Yes or not? Is tension. In tension is compression maximum. Is tension maximum. Understand?
Yes.
Is the, but we don't know how to find it. Now we don't know how to find that. We just know sigma equal E no y over no. We don't know how much is no. Yes or no? So we have to get how to find the sigma at a given point. There is another, because we know, it's moment is the resultant of the distribution of this normal stress. So we know sigma dA, and it means on the cross section we consider a small area dA. The force on dA is sigma dA. Yes or no? The distance from dA to the x is y. It must be equal to m, because m is the resultant of the distribution, of the normal stress distribution. It must be. So replace sigma by this y e from the dA is m, we can get no e y square dA must be m. Yes or not? Sigma must be m. So what's this? It's a moment of relation of the area of the cross section. It's not. You forget it. So we know no one is m e I. From here we can get it. From here we know no 1 over log is sigma over e 两边乘着取 y， 没想到。From here, log 分之一2个举一 y。 Yes or no?
Yes.
So from this two formula we can get sigma equal m y I is as a yes or no? About the is y yes or no? As a. This is the formula how to find the normal stress of a beam. Even although we get the formula just from the rectangular beam, in practice, by lots of, according to a lot of experimental, we know if the beam is a silent beam, the formula is good.
And silent.
Cylinder.
Oh.
For cylinder beam, the formula is good. So, how to use the formula?
Let us see. Here is oh. Here there is an example. It's difficult maybe. At first, I show you an example. Example. Simple, no? Okay? Simple. Simple example.
formula. Look at that. Here's the formula.
It's the
Sigma equal my over I.
negative. Is that negative?
Negative.
Is that negative?
Negative means if the stress is in compression, that is a negative. If in tension, is positive.
Sorry?
We doesn't. When we use this formula, we don't need the sign of negative. We just use this part. But arrow, my suggestion is arrow. We always take is absolute value, where take is maximum value. Is compression or intention according to the deformation, we determine the stress is in compression or in tension. Suppose I will show you some example. Suppose I give you example, okay? Suppose is 10 Newton is 2 meter, okay? The cross section is millimeter. Understand? Here is a cantilever beam.
Yes.
Is a rectangle beam. Is the dimension of the cross section of the beam. I ask you, find the sigma T max, sigma C max in the beam.
Okay.
Can you?
We can try.
You can try. Okay.
No, yeah.
I'm waiting you.
You can try.
Oh, it's easy for me. At first,
Larsie, you can do now.
Yeah.
at first, you have to know where is the maximum bending moment. Yes or no?
Yes.
Where is the maximum bending moment? You have to draw the moment, bending moment, diagram. Forget it. Draw it up. Where is the suppose the beam is made of concrete. If the beam will break, where is the first crack in the beam? Because the concrete is weak in tension. Concrete is weak in tension, is strong in compression. Understand? Where is the maximum bending moment? At first, you have to find it. You forget that? It's easy, it's very easy. 所以you are too slowly. You are too slowly. Where is the maximum of the bending moment? The fixed end.
Yes.
Yes or not?
Yes.
How much is it?
20.
20 Newton meter. Yes or no? Where is the x neutral x pass through the centroid? Pass through centroid. Yes or no?
Yes.
Where is sigma t max
The bottom.
in the cross section? Bottom.
Yes.
So you make a mistake. And first you have to know. Because you know.
T max is
Minus 吧 is minus 20
Yeah, minus.
is minus 吧
Yes.
It means the,
Yes,
the
T-max is,
information and here is like this.
Yes.
Yes or not? So the bottom material is in compression.
Yes.
The top material is in tension.
Yes.
So sigma T max is happened and here. Yes or no? Equal M Y max I Z. Yes or no? So how much is M? Is 20 Newton meter. How much is Y max? T is here. Y max is 50. Yes or no? 50 times 10. Yes or no? Change the unit to meter. Over how much is S? B H Yes or no? It's done. So in this way, we find the maximum normal stress in the beam. And that if the stress is more than a reliable stress, it means the beam will break. If the stress is smaller than allowable stress, it's safety.
What?
Allowable stress, one, you forget it.
No. Oh, this here.
Allowable stress.
But it's allowable stress fixed or you have to calculate, then you can compare the stress and allowable.
Yeah.
You have to calculate it. Both of them.
This stress, we call it is the practice stress. Is not.
Is equal to 1/12.
As in,
T into
you forget the formula? How to get the as in?
is equal to 1/12
Ah,
and BA
over
is Q plus
E
BA is Q.
H cube
BA is Q plus A over
because
over.
it's a pass through the center. So
Oh yes. Yes plus.
equal
So why he added 100 into
is zero. Yes or no? You understand? Change it to meter. US unit system.
Oh,
Oh, and it's
you make it meter, right?
Yeah,
Oh.
make it a meter.
That's why.
Yeah.
Is always this neutral plane at the same is always at the same.
Neutral, yeah. Neutral plane always pass through the center. For all kinds of cross section.
Then how about when we are going to calculate?
So, yeah, suppose is a T-beam, the neutral axis also passes through the center.
My question is, when we are going to calculate this
Eh.
one, this one will change.
Didn't change. But suppose sigma c minus equal to 20 is also yes or not same. Same.
That's the difference.
But we know from the bend moment, we know the compression is happening on the bottom of the, because it's a metal, so we know bend like this is not. So the bottom surface is this one. It's not so. When you get a number, get a reason, you have to remember it. C. You have to remember it. T.
Means the value are the same.
Yeah.
Then what's the conclusion you can make according to Taylor's conclusion?
Conclusion. So we know the formula is like this. This is the formula to get the normal stress. When we use this formula, we always use the absolute value. Absolute value. It's not how to determine the stress is in tension or in compression. You determine it by the moment. Understand? If you, because when you know the moment is positive or negative, you know it's bend like this or bend like this. Yes or no? So you know the normal stress is in compression or in tension. Understand?
Yes.
So it's easy. It's more easy. It's easy. If you use y